So good afternoon, ladies and gentlemen. So after a lot of deliberation on the medium voltage and the EHV side of things, we come down to the low voltage part of electrical distribution, where there is a specific subject called device substitution. Now, what is device substitution? When you have to convey to the electrical consultants and the end users that your LV switchboard is of excellent quality, you have to do what is called the IEC 61439 type testing. And when you do this type testing, and if you're going to be doing it with, say, L&T switchgear, but then there is a client who wants an ABB switchgear, then the problem is that the IEC standard in India does not allow you to do this device substitution. And this, according to me, is great injustice, and we will deliberate more as we go forward. Basically, why do we need standards? We need standards because, as we all know, electricity is a good servant, but a bad master. And therefore, we have to ensure that we play things in a safe way. If you look at the cause of electrical short circuits, you'll find that a majority of it is because of the ones which start off in some electrical switchboard somewhere. And why does this happen? Because not all electrical switchboard manufacturers play the game fair. With all respects to those, there are switchboard manufacturers who would say that, yes, I am also using aluminum bus bars. And when you look at an aluminum bus bar, you would not be able to make out by its look and feel whether it is a electrolytic grade aluminum or a commercial grade. And the difference in cost is 40%. The same applies for copper. You can extend this logic to the quality of wires which are used, the quality of lugs which are used, so on and so forth. So how do we, from the electrical industry and the end users, along with the electrical consultants, come together to find out what is important for us to look at from a safety, reliability, and convenience standpoint? A little introduction about myself. I'm the founder of the Money Group of companies. I started business straight out of college, so I've been 41 years in business now. Started off as an electrical dealer with the selling of miniature circuit breakers and distribution boards. Today, in money sales, we are authorized stockists for Legrand, ABB, Socomec, and Electron. From selling products, I went on to selling solutions from the year 1990 onwards. I started Load Controls, a switchboard manufacturing company. And that's when I got exposed to the kind of problems which a switchboard manufacturer has, particularly from an enclosure standpoint. When a panel builder has to scale his business, say suddenly he gets an order which is equivalent to 6 months of his sales, the biggest constraint he will face is in the enclosure. And so when I got an opportunity to go to Singapore in the year 1996, I spent about a week's time there, visited 18 panel building units, just to understand how the world makes electrical switchboards. And that's when I got to know that even in Singapore, you have panel builders who do it in the conventional welded design, and then you have the semi-modular design. And what stole my heart was when I saw a beautiful, completely world-class modular enclosure system. So I pursued this technology, went to several other countries, did a lot of research. And in the year 2000, I introduced the first modular technology, to the best of my knowledge, in South India, in my own company, Load Controls. And because I saw that the customers were really appreciating this technology and they really wanted more of this, in the year 2007, I registered my third company called Modutech Ready Panels Private Limited with the idea of selling modular enclosure systems. Now, when you talk in terms of any system in the electrical parlance, you talk in terms of compliance. You talk in terms of safety. And I'm proud to say that from Modutech, we are the only Indian company, or the Indian company which can proudly say that we have done this IEC 61439 type testing the maximum number of times, and there's a huge gap between where we are and where the rest of the industry is. We have done this testing for 15 times, not only in India, but also overseas. Not only with one make of switchgear, but 6 makes of switchgears, starting from ABB, Eaton, Schneider, LS Electric, Mitsubishi, and Siemens. Our switchboards, as you can see in this picture out here, all the doors are reversible, right to left, left to right. If last minute in the project you have a requirement where 2 modules, one below the other, has to actually be made into a bigger module in a welded technology panel, you can't do anything about it, excepting for adding another panel to the side. Here in our system, you will be able to remove the crossbar in the middle, change the door, and at site as well, you will be able to make all these changes. It is like typical to the IKEA model. You go to an IKEA showroom, you buy furniture, you bring it home, you assemble it yourself. The same way this goes. You buy a flat pack modular enclosure system, take it to your factory and assemble it yourself. It's like a Lego block. It can expand whichever direction you want, L shape, U shape. You must come to my factory once and have a look at how we manufacture these enclosures. It's very, very interesting. Now, to give you an idea about IEC 61439, let's start with where the whole thing evolved from. It evolved from what was called a decade ago as IEC 60439. And in 60439, the test was conducted only on the enclosure with the busbar system, which means it was basically on the short circuit, temperature rise, and IP clause protection. It did not have anything to do with the switchgear. So a decade ago, what the standards people who write out the standards, they put their heads together and then they said, no, we have to ensure that the switchgear is also involved. And that was the birth of IEC 61439. And when you look at IEC 61439, it is, as I said, when you do it with one switchgear, you can't extrapolate it to another switchgear in India. So but then the founders of the system were kind enough to say that when you do the testing, there are 3 types of approaches which you can have for the testing. 1, as tested. 2, by verification. You have a particular switchboard which you have got type tested, what you're going to be supplying, how do you extrapolate it from there to here. And 3rd, by calculation, which means you give the short circuit and temperature rise calculations and then justify how the panel is compliant. Now, the big challenge, one is the device substitution, but another big challenge is there, and I thought I must present this challenge in an electrical forum like this. As an exporter, if I want to export my panels, IEC is recognized only in certain countries in the world, as what is indicated here. If I want to supply my panels, which is IEC 61439 type tested, but I want to supply it to America, Americans say, no, you have to get it type tested as per UL standards. If I have to supply it to Russia, they say, no, you have to supply it with testing as per the GHOST standards. Japan, they say JIS standards. How fair is this? I mean, we are all here concerned about electrical distribution and safety. Why can't the brains of the world sit together and say that let's all agree on one standard? I hope this conversation will continue further from here. Now, coming to IEC 61439, there are 3 people who are basically involved in a particular project. 1 is the end user. He is the person who puts the money in and specifies what he wants. 2 is the electrical consultant. He comes in and takes the brief from the end user and then makes his technical specifications in terms of how exactly the safety, reliability, as well as cost competitiveness is going to be introduced into that project. And 3rd, of course, we have the panel builder. Now, this panel builder, of course, has to be competent. He has to ensure that he is absolutely capable of doing the panel in a safe, reliable, and convenient way. So if that has to be the case, then what is important is the element of trust that gets developed between these three parties. And IEC 61439 is really a differentiator between the men and the boys. I want this forum to also sort of recognize that we shouldn't be aiming at absolute perfection in things what we need to be doing, but we need to be focused more on progress. Why I say this is, you take Australia for instance. Australia follows the same IEC 61439, they call it the AS 61439, but there, till a rating of 3120 amps, device substitution is permitted. Now, what is the difference? They're probably much ahead of us when it comes to looking at the systems and processes which gets into the electrical systems. But they are allowing it, and we are not. So this is where, we really need to be debating these points in forums like this to understand how we need to come onto a same platform. Now, while they say, yes, it is permitted, they have certain conditions attached. That is, when you're type testing, say, with Schneider, and then you want to substitute with ABB, then they say that please ensure that the watt loss of the breaker which you have type tested it with Schneider, the ABB one is equivalent to that or lesser. Similarly, for temperature at the terminals, see that the device is having the same temperature rise or it is lesser. And also, if you look at the kind of space which you have type tested the switchgear with, see to it that you are going to have the same amount of air inside the compartment so that the temperature rise is taken care of. So basically what this means is that there is a huge ease of doing business. And this is very, very important, in my opinion, for India also to progress in a rapid pace as what it is progressing, and with an ease about doing that. Panel builders, for example, we have to look at the availability of sufficient details of these device testing. I told you that, temperature, terminal temperature, and how much of this is really available in the public media. ABB is not going to be publishing these things very easily. And you go and ask them for these details, as long as their switchgear is being used, they'll probably share it very comfortably. But if it is not so, what do? There are challenges which specifiers also have. Quite a number of specifiers need to educate themselves also, with all respects to them, in terms of what exactly is the standard and what is the interpretation of the standard. So what is the rejection criteria? It is something which needs a lot of understanding. And for specific projects, like for example, if there is a project where there is a room dimension limitation, you may need to go for ACBs one on top of the other. And if you've type tested it for a single row, the chances are that the consultant may say, no, this is not acceptable. So how do you deal with these kind of situations? Ultimately, the end user has to look at the cost-benefit analysis. And this is where I feel that there is a lot of trust which has to be built between these three parties who come together to execute a project. So, end of day, what is important is educational marketing. And this is, like how Electric Mirror is conducting this kind of workshops. We have a lot of exhibitions which we participate in. There is a lot of articles which gets written in all these technical magazines. It's very, very important that these kind of educational communication keeps going faster and smarter in terms of reaching the right kind of audience. COSMA is a Control Panel and Switchgear Manufacturers Association. IEMA is the Indian Electrical and Electronic Manufacturers Association. So all these associations also have a big role to play in decimating all this kind of knowledge. So finally, to conclude, progress is very important and it needs to be done keeping intelligent safety in mind. So when you look at IEC 61439, yes, use the standard by all means, but please go beyond the standards to find that cost-benefit equation. Yes, the standards differentiates the men from the boys, but then if it is not exactly matching, and it is very difficult for any manufacturer to claim that he has got all the different tests covered. It's not possible. So we have to think global, but we have to act local. And this is my message that, progress is much, much more important than perfection. Thank you.